So let's just start off by showing all the forces that are present in this triangle. So, for example, here we have this triangle, and we see this angle. We know that this is 30. And we have, let's say, this box going upward. Awesome. So we first have to start off. We can mark the force of gravity going down, which would basically literally be a straight line going down. That, as we know, is the force of gravity. And the next part is the force, the perpendicular force, which is basically going this way. And we are going to label it like this because this is the perpendicular force. And then there is another force as well, which is the force that is parallel to this. So basically that's our little triangle that kind of shows all of the forces. Now the force going down, Fg, is the mass. And in this example, the mass is 15 newtons here, as we see right there. So the next step is we're just going to pull apart this triangle. We're first showing the force of gravity. I'm going to change the color. Then we're showing the force that is perpendicular. And then we're showing the force that is parallel. So now we know that this angle has to be 30 degrees because there are opposites here. So this angle is 30, same as this. So we know that here this is the adjacent angle and this is the opposite angle. Now we can use formulas to help us find what the opposite angle would be. So it would be h times the sine of theta equals the opposite angle, and h times cosine of theta equals the adjacent angle. And h is really just going back to this force. So let's start off, and we really only need to find the parallel force. So to find the parallel force, it's going to be h, which is 15 newtons. Remember, the adjacent, the opposite is this one. So 15 newtons times cosine of 30. Sorry, times sine, because sine is what's going to give us the opposite angle, times sine of 30 equals 7.5 newtons. And this is FA, the parallel angle. So that is our answer to number 1. A equals 7.5 newtons. It's also the same with the perpendicular. We're just going to solve a different one. We did previously solve it. And the perpendicular is 13 newtons. Now, for the parallel force of A equaling 0, we basically kind of have to work backwards. So what would be the force that you need to apply in order to have 0? It would basically be this equation, but backwards. So we have sine of 30 still exists, equals 0 newtons. And here we have, because that's what the accelerated f of a is, times a number, which I will call it x. So even if we go divide it to cancel that out, sine of 30 by sine of 30, it cannot be divided by 0, so x would equal 0. So what force would it need for the acceleration to be 0? For part B, the force would have to be 0 newtons.